Assalamualaikum warahmatullahi taala wabarakatuh. So hari ni kita, dan today we need to understand the Gauss law. Okay. So we start with this statement: if the surface does not have any charge inside the enclosed surface, then the electric field through the surface is 0. Okay, so this one is the first statement. So we continue. If there are some charges inside the enclosed surface, so the question is, then how to calculate the electric field. How to calculate the electric field? So the Gauss law. So can be applied. So we use the Gauss law in order to calculate the electric field. So then we need to understand the Gauss law. So if there are some charges inside the enclosed surface, then how to calculate the electric field E? So we apply the Gauss law. So now today we need to understand what is meant by the Gauss law. So I give the definition of the Gauss law. What is the Gauss law? So the Gauss law is the electric flux. So the electric flux, the symbol is psi. The unit is Weber through a closed surface. Through a closed surface surface is given by this equation. So the equation is psi equals to the total of Q over the epsilon naught. Okay, what is what is meant by the total of Q is the algebraic sum of the charges enclosed by the surface, and then the epsilon naught actually is your permeability of free space. So then we continue. Psi also can be written as psi is equal to the electric flux of dot A, and from the Gauss law, psi is equal to the total of Q over the epsilon naught. So we combine these two equations, then we have the EA is equals to the total of Q over the epsilon naught. Then so where A is a area, of the surface, the unit is a meter power of 2. So this one is the equation normally is referred to the Gauss law. Okay, so we continue for the electric field. So electric field produced by a point charge. So we apply the Gauss law to understand the electric field produced by a point charge. Okay, here is the point charge. Q is here. Q. Okay, so the sphere in the 3D. So here is the point charge. And so we take a positive charge and then we draw the electric field line. So here in the 3D, so because the charge is positive, so the direction of the electric field is moving out from the charge in the 3D. So I explain about the surface area. This one is the surface area. A, and then A is equal to the 4 pi r squared. So this one, before we continue, so I just note here 3D is a 3D sphere, and then this one is the area of the 3D sphere, so it's equal to the A 4 pi r power of 2. The r is the radius here. Then we continue. So we start here. So from the Gauss law, so we have the flux is equal to total of Q over the epsilon naught, and psi is equal to the E dot A. Therefore we have this equation: E dot A is equal to the total of Q over the epsilon naught. So we continue. E times the A. A is the 4 pi r squared. So 4 pi r squared equals to the total of Q over the epsilon naught. Okay, so we continue. Therefore we have then E is equal to the total of Q over the 4 pi r squared epsilon naught, and we can write as a we arrange the equation 4 pi epsilon naught. Then here is because we have only one charge, so total of Q is equal to the Q over the r squared. Then we can have the equation is equals to the E is equal to the Q over the KQ over the r squared, where K is equal to 1 over 4 pi epsilon naught. So this one is the electric field by the point charge positive Q here. For that one is for that. Thank you.